Okay, so another example of rational expression equation applications, if you would, is this idea of a proportion. And so first of all, what is a proportion? Well, this is any equation where I have a fraction equal to another fraction. So a fraction equals a fraction. So say something we have like x over 3 equals 10 over, let's say 15 or something like that. All right, so this is what we call a proportion. It's an equation where a fraction is equal to a fraction. And what's really nice about these is you can solve them by doing what's famously known as cross multiplication. So this equation has the equivalent equation. If I multiply 3 times 10, that's equal to 15 times x. And so if I finish this particular problem, we'd have a 15x equals 30, divide both sides by 15, and we would get x equals 2. So we're basically saying that 2 over 3 is equivalent to or the same as 10 over 15. So that's what's really nice about solving a proportion problem, is that cross multiplication can come into play. Alrighty, and so the next round of problems that we're going to do are famously known as proportion problems. Our challenge is to set up a fraction equal to another fraction. Once I get that done, we can basically solve by cross multiplying, and everything is all good. So let's see that in action. Alright, so the first classic type of proportion problem is what we call similar triangles. And all we're basically doing here is, again, we want an equality, and when I have a similar triangle, that means I usually have some angles. I should have indicated the angles are the same. The angles are the same, but one triangle is probably larger than the other. And what this means is that the sides are proportional to each other. And so here's where it gets a little challenging. When you're setting up your proportion, make sure you're consistent. So here's two different sets set up for the same problem. One idea is to say that 6 is to 8. So I'm kind of in this one triangle here, and I'm basically comparing this side to this side. So to be similar, right, the fraction on this side has to compare the similar sides. So this would mean that 10 is to x. So that would be a classic setup. Of course, if you wanted to go the other way around, you can say 8 is to 6, like x is to 10. So now what I'm doing is comparing this side to this side, and its comparison would be here to here. So notice I have a proportion in either case. And of course, another way to do this is you can actually compare side to side. So we can say 6 is to 10, right? So this guy to this guy would be the same as 8 is to x. So that would be another one. But notice what I'm doing. No matter what one I have, I'm being consistent. Whatever fraction I set up on one side, I'm doing something similar, a similar ratio to the other. And that's exactly what I'm happening here, right? These two sides represent the same type of side. So 6 is to 10, like 8 is to x. Or you just keep the two situations separate, and we say the fraction 6 over 8 is equivalent to the fraction 10 over x. So they're similar. The ratios are the same. Excuse that cough. And it doesn't really matter. As a matter of fact, we could have even said 10 over 6 equals x over 8. So we have 4 different setups to do the same problem. What's important is the consistency. So to solve these, look what happens when I actually go through and solve them. Here I cross multiply, and I would get 6x equals 80. Divide both sides by 6 and do a reduction. I think 2 goes into each of these. What we get is 40 over 3 as our answer. Look what happens if I solve this one, right? We get 80 equals 6x. Divide both sides by 6, and lo and behold, we end up with the same answer. Look what happens here, right? If we cross multiply, we get 6x equals 80. Divide both sides by 6, and we get the same answer. Last but not least, cross multiply, we get 6x equals 80, and I think we already know the end of that story. So that's what makes proportion problems very challenging. I have 4 different setups, but you know they're all right because they give us the same value. So when you guys are showing your work on Canvas, if some of you are getting different values than others, that means your ratios are not exact. So there's your challenge. You know you're setting up two fractions equal to each other. Just make sure your ratio on one side is similar or equivalent to the ratio on the other. Whether you compare one triangle to the other, or you compare sides to sides and sides to sides. Alrighty? So I'm going to only do one set up here for the next set. I'm just going to go ahead and say that 21 is to 24, right? So this side is to this side. And if we look at the idea, right, the similarities, this x and this 21 are common. So they both are up in the numerator. And this 16 and this 24 are common. So they are both in the denominator. So 20 is to 24 in this triangle, like x is to 16 in this triangle. So I'm keeping the two triangles separate, and I'm comparing this side here to this side there, and making the same comparison in the other one. So my ratios are consistent. So how do we solve this? We cross multiply. All right. Oops. 21 times 16, that's a 24. Cross multiply. Divide both sides by 24. And right now we get x is 21 times 16, all 24. And again, it's easier to keep things in this form rather than multiplying, because I can see that 16 and 24 both share an 8. Right? 8 goes into there twice, and it goes into there 3 times. And then 3 goes into 21 7 times. So putting things together, it looks like x is equal to 14. So 21 is to 24 like 14 is to 16. We have equivalent fractions. Okay? The next type of proportion problem, we'll do one initially and then we'll do several more, is an actual word problem. What's nice about these up here is they're nice and visual and we can actually see the relationships. But in this word problem, we got to work out a little bit. So the problem is this. A market researcher finds that 3 out of 10 students at GCC are Dodger fans. If you know that there are 21,000 students at GCC, how many are Dodger fans? So we got to be careful here, right? We know we're setting a proportion. I want to be able to set up some fraction equals to some fraction, all right? And my unknown right now is the number of Dodger fans. All right, that's what we don't know. So the Dodger fans. What we do know, though, is that in a sample of 10 students, 3 of them are Dodger fans. So I see a fraction there, right? So there's 3 Dodger fans. So the top I'm using is Dodger fans, and here's the total sample space. So of this 10 total students, 3 of them were Dodgers. There's my fraction. So that should be equivalent to, right, the same fraction on this side. So how many total students are there? Well, there's 21,000. How many of these 21,000 are Dodger fans? Well, that should go up in the numerator, but I don't know what that value is. So again, my ratio is Dodger fans to the total sample, and I'm setting it equal to Dodger fans to the total sample. So I have a good proportion here. Everything is equivalent. So how do we solve it? Well, as we've seen, we cross multiply. So we get 3 times 21,000 equals 10 times x. If I divide both sides by 10, we get x equals 3 times 21,000 over 10. And again, it's pretty easy. Zeros cancel out there. And so it looks like we have 3 times 21 is 63 and a couple of zeros. So it looks like there's 6,300 Dodger fans at GCC based off of this market research analysis. I actually think there's more Dodger fans because you guys all know they're a much better team than the Diamondbacks. But hopefully one day they'll start playing some ball, right? So sorry for that stab at you D-back fans because I am a Dodger fan. All right? So let's take a look more of these types of word problems in the next video because this one's already getting a little long.